Good morning, everybody. Today is Wednesday, um, April 29th, 2020. Today we're going to talk about something called combining like terms. So I'm going to kind of write that up here as I'm talking. Combining like terms is something that you're going to use throughout the rest of algebra. Okay. We've already done this a little bit, but not enough. So we're going to practice this today, especially now that we've kind of worked with our vocabulary a little bit. We've talked about coefficients. We've talked about terms. Okay, so now we're going to work with like terms today. Okay, so just a little reminder here from yesterday's IXL. Each one of these call a term, and then we're calling the constant number in front of each variable, we're calling that our coefficient. Okay, so in this case, our first term is 4t, coefficient's 4. Second term is 3t, the coefficient of the second term is 3. And then finally, the third term is 2t, coefficient is 2. Okay, so that's just a little review from yesterday. So when you're combining like terms, let's first think about what exactly is going on. Okay, so I want, let's say T, in this case, is our hourly wage. Okay, you're all getting to the age where maybe you're going to start looking for some sort of job at some point, some sort of extra income. Well, when you get your first job, you're going to get something called an hourly wage, and that's basically how much you're getting paid every hour. So let's think about this a little bit. T is our hourly wage, and that always has to stay the same, right? When you get a job, you're not getting a raise every time you go to work, and you're not, getting a pay cut every time either. That'd be pretty terrible. But you're gonna make the same amount of money. So let's look at this expression here. And let's say that T in this case, maybe you're making $10 an hour. $10 per 1 hour. Okay, so in this case, we're using T to represent the wage, and this expression here could represent something like how much money you make after working some amount of hours. And let me explain that a little further. Okay, so let's say this is let me use a different color. Let's say this is how much money you make on Monday. This is how much money you make on Tuesday. There we go. And then we'll say this is how much money you make on Wednesday. Okay. So on Monday, we're making 4t. So in other words, we said t is our hourly wage, so 4, maybe that represents how many hours we worked. Okay. So we have 4 hours, and then we're working for $10 every hour. And what you'll see is these units actually cancel out, and this gives us 4 times 10, $40. Now think about that. If you work for 4 hours and you're getting $10 each hour, that should not be surprising. So let's do the same thing. I'm not going to write everything out for the others. Let me use green though. So we have 3t. If we're working for 3 hours at $10 an hour, it's going to be $30. And then finally we have 2t here. So that means that we're working for $2 or 2 hours, making $10 each hour. So on Wednesday, maybe you make 20 bucks. So if you're looking at how much money you're making in a week, you can add up 40 plus 30 plus 20, and this will give us 40 plus 30 is 70 plus 20. And that'll give us $90. Okay? So $90 with this scenario. Now I want to show you that we could actually solve this in the same question in another way. And this is going to be what's important for combining like terms. So let me put a little space over here. So notice that we have 4t, 3t, and 2t. These all have t in it. So there's something we can use called the distributive property, which you may or may not have learned about. You should have at some point, but I know everybody has seen different things. This is kind of the backwards of the distributive property. And what you might notice is since we have a t in each term, we can actually factor something called factoring out this t. We can put it outside and rewrite it like this. Okay? So again, like what we're doing, if you wanted to undo this and go back to where you started, you would multiply t times 4. That would give you 4t. T times 3 would give you 3t. Plus 2 times t would give you 2t here. So that would be if you wanted to undo it. But we don't want to do that. So at this point, we're going to take our t, and we're going to multiply by this 4 plus 3 plus 2. Well, 4 plus 3 plus 2 is 9. Well, what you should see here is that now we see we're working for 9 hours at $10 an hour. Well, if we plug in 10 for t, 10 times 9 is 90. Okay, so we get $90 again, which you should get the same answer, right? So a way you could break this apart in each day, or you can recognize since we're multiplying each of these terms by t, or each of these terms has t in it, you can actually just add up the coefficients. That's what we did here. We added up 4 plus 3 plus 2. 4 plus 3 plus 2 gave us 9, and then you multiply by t. That gave you the same thing. And when you break it down, well, 4 hours on Monday plus 3 hours on Tuesday plus 2 hours on Wednesday. Well, if you add all those up, that's 9 hours. So it's the same way to look at the same problem. So when you combine like terms, well, we're not looking for a number here because they actually don't tell us t up here. I just, it was hypothetical. So in the end, your final expression is going to be like this. Well, let's do another. Let's do one a little harder. Let's do this. Okay, so now we're going to combine these like terms. So for your answer, you're going to have an expression, right? It's going to be something with s's, right? That's our variable here. Let's see, these all have an s in it. So all you have to do is we can put the s outside the parentheses, and then add up each of the coefficients. I'm going to rewrite that So let's add up each of the coefficients. 9 plus 6 plus 5 plus 2. And then we know each one of these terms here has an s in it, right? So each coefficient that we wrote here is being multiplied by s. So let's put this s outside. Okay. So when you have this variable outside the parentheses like this, it means we're multiplying everything inside of it by that. So we can rewrite this now. This s is going to stay the same. And we just add up the coefficients. 9 plus 6 is 15, plus 5 is 20, plus 2, 22s. And that's the proper way to write it for your final expression, just like this. You put the coefficient first, then the variable. All right, let's take a look at a couple others. Let's look at this one. All right, so in this case, now we have numbers and we have letters. Okay, notice that each term does not have an a in it here. So what you want to do is we want to list our constants. Let's see, we have 5, and then we have a -5. And then we're going to look at, let's see, we have our a, that's our only variable here. You'll see with some of the other questions you could have more. So let's see, we have an a here, so we have 1a. Right, we just don't write in the 1, but we could always add that in if we wanted to. You just 1 times a is a, so you're not going to usually see that. So we have 1a, and we have another 1a. So to combine like terms, what you have to do is we're going to add up our constants. These constants are like terms. They don't have the a in it, so they're different than these terms. So we add up 5 plus -5. Okay, you should know from the IXL on Monday that'll give you 0. It's the same thing as 5 minus 5 is 0. Now down here we have 1a plus 1a. Oh, that's 2a's then. Okay, just add up the coefficients, keep the variable. So we have 2a. So our new expression here, we know 5 plus -5 or 5 minus 5. This went to 0. And then we had a plus a was 2a. So that's our final answer, 2a. Okay. Let's look at challenge 1 or 2. I want something even a little bit different. And this will work. Okay, so for this one, you might notice that we have a b squared this time. And that's in each term here. Every term has that b squared. There's no just numbers in here. So we're going to get, what we're going to do is we're going to put this b squared to the side, and we're going to add up the coefficients here. So we're going to do 16 plus 15 plus 6 minus 5. Alright, and then you need to figure out what that is. 16 plus 15 is 31, plus 6 is 37, minus 5, 32. So you should get 32b squared. And then you're going to want to type it in like this. Oops, not like that. Like that. Alright. We'll do this one actually. I know it looks really hard, but we can do it. We have all the skills too, and it does actually, there's something I want to talk about with it. Alright, so this one I know looks a lot nastier. So what we need to do is we need to see what terms we're working with. Okay? So I see we have a q squared r s squared. So I'm going to write down, I'm not going to write down the coefficients yet. I'm just writing down what variables we're working with. So we have this here. It's from here. We have q squared times r cubed. Q squared r cubed. It's right here. Looks like we got another one. And then we have q squared r cubed again, so it's the same thing here. Same thing here. So you see, we actually, it looks like it's a big mess, but really there's just two terms we're working with. Okay, so this first one, well, there's nothing to combine this with. So you just are gonna, your only term here is 37 q squared r times s squared. But down here, we see we have all four of these terms have the same, they have the same q squared times r cubed. So what we can do is the same thing as usual. We're going to I'm going to put this to the side, q squared times r cubed. And then now I'm going to add up each of the coefficients in front of the q squared r cubed. So we have 41, 40, negative 38 or minus 38, negative 43, or we can think of this as minus 43. Alright, now we need to figure out what goes inside of here. So let's see, 41 plus 40 is 81. 81 minus 40 would be 41, but we're only taking away 38, so we'd want to add 2 more, 43, minus the 43. What do you know? This gives us 0. Apparently these all cancel out. If I did my math right, let me double check it. Looks good to me. So these actually all cancel out. So our final terms that we're going to write in is we have this, and then we have 0 times q squared times r cubed. Well, 0 times anything is 0. So these actually just cancel out. The only term we're left with here is 37 q squared r times s squared. So let's write that in. 37 q squared r s squared. There you go. So at this point, I think I'm going to call it quits here for the day, but I'm going to see how you guys are doing on this assignment. If we're having a hard time, we will review this more. Maybe I'll make another video. But this is a very, very, very important skill. I can't stress that enough. You're going to combine like terms for the rest of math, so you need to know this. Just take some practice. Yeah. Some practice, and maybe it helps if you understand it a little bit too. So make sure you're really thinking about it, especially that first example I covered. So everybody have a great day. Miss y'all. Hope you're all doing great, staying healthy. Goodbye.